Today our topic is related to section 1, in which we will have to study about forces and motion over there. Forces and motion. So basically, let's start about forces and motion. I will explain about kinematics portion and dynamics portion in both of these sections will be explained over there. And the basic thing which we will go for forces and motion section, that is related to velocity and acceleration over there. If I go in the detail of this, I will say both are similar, but in physics, they are not quite same over there. As we say speed and say we say about speed and velocity, we are simply saying how they are fast going on, and both are measured in meter per second. Like if I'm going to define that, but speed and velocity, speed and velocity. If we talk about this, we can say both are the same. Similar, but in physics, they are quite not same over there. Speed and velocity both have simply, if I define both of them, I will say how fast a body is going on, how fast a body is going on. Both are measured in the scales of units with meter per second in SI base per units over there, can be measured in kilometer per hour, can be measured in miles per hour, or like that we can take over there. But there is a very cute difference between them, that you need to know that speed is just how fast you are going on, like 30 or 20 meter per second. Like speed is having only magnitude and unit. That is for speed. No direction is going to be taken into account. And regardless what is the direction over there, how fast you are going on is called speed over there. But in case of velocity, we can say, however, must also have the direction specified. Like if I'm saying that I'm going towards velocity, then I will say magnitude plus unit plus direction also. Like if I say 20 miles per hour is going on in north direction or south direction, it means that is the velocity you are talking about. And you can have the objects traveling at a constant speed with the changing velocity. For example, when a body is moving on a circular path, for example, this is the circle, and object is moving in that with the constant speed of 30 meter per second. But at every point along the tangent, along the circle, it is having a tangential direction at every point over there, which is changing. So changing the direction, it means that is called changing in velocity over there. So I can say this can happen when object is changing direction while staying at the same speed over there, is happening when body is revolving around the fixed point on a circular path over there. And for any object, the distance moved will be average speed and time taken related to formula. Then I will say the average speed is having the formula over there. Average speed is equal to total distance moved or distance moved. Distance moved over time taken. That can be total time taken and total distance traveled will be taken by this formula. We can take it as, if I make a triangle for this memory, then I say it is SBT over there. If I want to calculate distance S, then I will say it is equal to V multiplied T. If I want to calculate speed over here, then I will say it is S over T, distance over time. If I want to calculate time, then I will say it is distance over speed over there. So this triangle is to use and manipulate the formula in a proper way of a sequence. Different examples can be taken to solve distance, speed, and time related to this. And when I talk about acceleration, then I say acceleration is to be stated as acceleration. Acceleration is basically, we can define this, that how quickly velocity is changing. How quickly velocity is changing with respect to time. Velocity is changing with respect to time over there. And if I am going to explain this, I will say acceleration is not same as velocity or speed. Acceleration is basically changing in velocity. So the change in velocity can be change in speed or change in direction or both. So change in, if I am writing about this, I will say here that change in velocity, as I have mentioned above, in velocity can be change in speed, according to magnitude, can be change in direction, or we can say, wait a second, change in direction, or it can be both over there. Are going to show the changing in velocity can be change in speed, can be change in direction. For example, you are saying that is a constant speed, as I have given the example above, on a circular track, and saying change in speed is not happening, but direction is changing. It means acceleration is available over there, which is showing the change in velocity phenomenon behind it. And we have only to vary the change in speed bit for calculations if I want to calculate about the acceleration, because calculation will not be shown in the form of direction change in velocity over there. Unit of acceleration, if I talk about that, then I will say its unit is meter per second square over there. It is a vector quantity. It is also having a direction. If I talk about direction in case of circular motion over there, then I will say that is related to direction of motion, always directed towards the center in that case. And if I talk more about it, then I will say here that there should be a formula that should be taken. A is equal to v minus u over t, or acceleration should equal to change in velocity over time taken over there. And this time taken should be taken as how velocity is changing its direction. If I am not involved in the calculation, then direction is enough. If calculation is involved, then I will say it is equal to v minus u. If I make its triangle also, then I will say that it is v minus u and a and t. A is equal to v minus u over t. T is equal to v minus u over a. V minus u is equal to at. That is also the first equation of motion over there. So there is slightly tricky thing with the formula. The v minus u means working out with change in velocity rather than just the simple value for the velocity or speed in. So it is a negative value over there. After that, if I am getting here a negative acceleration value, then it means something is slowing down or decelerating. If acceleration is negative value, then I am saying something is slowing down. Are you applying the brakes to the moving car over there to stop it? Slowing down. And are decelerating over there to decrease the speed with respect to time over there. Okay. And if I go in its detail, then I will say here, if I am going towards the third equation of motion to relate distance, distance, final speed, initial speed, and acceleration in a proper relation, then I say it is equal to v square is equal to u square plus 2as should be taken. And here v is the final speed, u is the initial speed, and is the acceleration with which body is accelerating, and s is the distance traveled over here. And so I can say here it can be manipulated. For example, he is saying there a car is traveling with the speed of 23 meter per second and have some acceleration of 2 meter per second and built up a distance traveled over 100 something meters over there. And he is saying what will be the speed when it reaches to the complete distance over there. So final speed can be calculated. So I will put all the values of u, a, and s there, and I will calculate my v square as a final velocity over there. So this should be used in acceleration speed time graphs over there. Should be also be taken over there. If I move towards distance time graph, then I will say distance time graph and velocity time graph. I will try to draw a figure over here in which I will try to explain the different stages of steady speed, stopped, acceleration, deceleration, like that. If I want to go for distance time graph, then I will say here, let's suppose I'm trying to draw a graph over here. I'm taking a distance time graph over here. Here it is distance to be taken on y-axis and time should be taken along x-axis. Then, for example, I'm saying graph is going straight line here. Then I am saying it is stopped for some time. It is not being changing. And after that, what happens? It starts to increase. And then it becomes again parallel over there. So during that phenomenon, I will say here it is the increase in distance traveled with respect to time. I am saying here it is constant speed over there. And in this case, I will say it is stopped. Then I can say here it is accelerating. And here I am saying it is decelerating over there. So when I am saying these different parts of distance time graph of motion of an object, then I can say its gradient of distance time graph give me the speed of object over there. Always remember, gradient is basically in mathematics, if I go for that formula, that is y2 minus y1 over mx2 minus x1 should be taken over there. If that is a flat section where it is stopped, like this one, this flat section is showing, if graph is showing a flat section of the curve, then I say the object is stopped completely. For number third, I will say here, if it is steeper means it is going faster, it is accelerating. If the graph is steeper, then I will say here steeper, STW, steeper. Then I say it is going faster over there. At number 4, if it is, I will say here, curve getting speeder means it's speeding up, increasing, and when it is traveling cutoff curve means slowing down, then it is decelerating. Both phenomenons can be shown by this graph over there. So in this section, always remember that as I have written the gradient formula, it is rise over run. Rise means up, run means horizontal distance. Then both should be taken and speed can be calculated by using this graph. We can also calculate average speed of object over a period of time by dividing the total distance traveled by time it takes to travel the distance, that distance. So average speed over the whole journey will be shown the maximum value of the, for example, this y-axis is having the value of 500 meters over there, and the time is having its value at the end over there. I am simply saying there it is, for example, should be taken as 80 seconds or like that, or 80 minutes over there. I'm taking here 80 seconds. So average speed can be calculated by total distance, that is 500 divided by 80, should be taken as 8 6 the 48 2 and 5 6.25 meter per second should be taken as average speed over there. If I am this was my distance time graph over there. When I am going towards speed time graph over there, then I will say here that speed time graph should be related in such a way that now I am taking velocity or speed on y-axis, and x-axis I'm going with the time there. Here I'm taking time, and here I'm taking speed over there. For example, I'm making the curve in the same pattern a little bit. Then I'm saying it is going with the constant speed. Then it is a constantly increasing speed. Then the speed becomes constant for some time. Then it is again increasing in this way to show some little bit curve. Then it is going to steady speed over there. Then it is, I am saying that it is completely decelerating to stop the car over there. So these sections, if I take in explanation over there, then I can say there is a constant acceleration is available during this section, acceleration. And here it is steady speed, no acceleration, acceleration is 0. Steady speed in this section. After that, again, increasing acceleration because now it is more steeper. So I will say here it is increasing acceleration is available. Again, now it is constant speed. I can say here steady speed, no acceleration here. Steady speed. Again, I am saying now I'm applying the brakes over there. Then I am saying it is decelerating over there. If I go for the characteristics explanation for this curve, complete graph over there, I am saying here gradient gives me the acceleration. Gradient gives acceleration over there. After that, gradient, we can say flat sections represent steady speed. Like steady speed is shown over here, steady speed is shown over here. So flat sections shows steady speed over there, means there is no acceleration. Steady speed or steady velocity over there. So steeper the graph, the greater the acceleration or deceleration. As much it is steeper here, this is also more steeper over here. So that is, I will say here, when more steeper, then we say it is having the greater acceleration or deceleration. Greater acceleration or deceleration over there. After that, if I talk about the remaining sections, uphill section are acceleration and downhill sections are deceleration. Like it is increasing acceleration. This is uphill. This is uphill means it is going upward towards the hill to make like that. So it is acceleration. And when it is downhill, then it is decelerating. Uphill speed is going on, then it is acceleration. And when it is going towards downhill, then I say it is deceleration over there. If I talk more in detail over here, I will say area under graph for speed time graphs over there. Area under graph whole complete area will give me the distance traveled over there. Area under graph will give distance traveled or displacement traveled or distance traveled. Both can be taken into account over there. So this was the complete detail about the acceleration phenomenon over there. So always remember these main points, that acceleration is represented by a rise over run according to gradient formula, rise for speed over run for time over there. is giving you acceleration, and speed at any point simply found over there by reading the value of the velocity axis over there. For example, you want to calculate the speed at this point, just read the y-axis at that point and you will get the value. And distance traveled at any interval is equal to area under graph. Always remember, distance traveled up to this speed can be taken as area under graph of this value over there. So this was related to our motion of velocity, acceleration to be taken into account. In the next video, I will talk about mass, weight, and gravity. And thank you so much for today work. But I am going to quick revision of this section. I will simply say here that speed and velocity both have the same magnitude, but and unit like that, but they have the difference that there is a direction involved. In case of velocity, acceleration is present over there. Acceleration is taken in the form of two main formulas. That is, A is equal to, here if I add, A is equal to V minus U over T. So this relation is used in mostly calculations over there. And second relation is related to distance, speed, and acceleration, and time is not involved in that case. After that, we have talked about distance time graphs and we have talked about speed time graphs over there. Thank you so much for today. See you tomorrow in the next class. And stay connected, stay tuned. Thank you so much. Kindly subscribe my channel.